Hello, today we will see how R eval the function. So let's start. First, let's see. First of all, R already know the something. Okay, you don't need to tell him. Okay, suppose the data structure. Okay, all right. So vector, list, data frame, array, and all the other data structure he already know. Okay, you don't need to tell that this is array, this is vector, this is list. Okay, you don't need to tell him. Okay, he already know. If you type the console, you if you type in the console data frame dot something or any data structure, then what he do, it return to you. Okay, he because he already know, that's why he able to return it. Okay, similarly, the keyword and operator, like keyword like for, if, else, while, switch, and many other keyword is available. He also know the meaning of for, if, else. You don't need to tell him. Okay, similarly, the operator, he already know what is the meaning of plus, what is the meaning of minus, what is the meaning of equal to, and okay, you don't need to tell him. Similarly, identifier or symbol, so he already know the sum of the meaning, like what is the meaning of sum. He already know sum is a function which is implement in the standard library in R. I will talk about R evaluator after a few seconds. First, let's look this command. I mean, first look what is lexer parsing or semantic doing. Okay, suppose you type this command quote is a function by which you stop the R evaluator from the evaluation. Okay, so you only stopping the R evaluator, but under the hood it is lexered parsing and semantic check. Okay, because you quote only effect on the R evaluator, not rest of them. So when you type this command, what happens that it tokenize by R lexer. So he already know one is a number data, numeric data, plus is a operator. Okay, one is a numeric data. You don't need to tell him. And after that it passed the code and he do semantic checking. So he check grammar and verify the syntax. So there are three types of syntax in the programming language. Noun, there is a infix syntax. Okay, 1 plus, for example, 1 plus 1, it is a infix call, infix syntax. Prefix syntax like plus 1 1. And there is a postfix syntax. Ever you, if you use Dart programming language, you see these things: string, question mark. So question mark here, operator. Okay, not operator but opcode function. Okay, it is written as a postfix syntax. So he what the duty of semantic checker is, he verify the syntax. So now what he do, he verify the syntax 1 plus 1, that means that it is a infix syntax. Now hit generate a expression like plus 1 1, and then after you pass this expression to the R evaluator to evaluate. Okay, now let's see what if you type this command. First what he do, he check all the list of operator which is present in the library, R library, and he match match from this operator, from the list of this operator. Now if he did not found anything, then he gives error. Okay, and he gives error like I expected greater than symbol, but you type this. Okay, so this type of error message uh, he give to you. Similarly, if you write anything in the backticks, it become a identifier or a symbol. Now this time he did not match the operator, he matched from the list of symbol. And so there is a term like symbolic expression. He don't know this type of symbolic structure. That's why he gives you error. Okay, he know this type of symbolic expression, as you can see in the slide, in the green box. So he know this type of symbolic expression, but he did not recognize the infix way of symbolic expression. That's why it returned the error. Similarly, if you write this symbolic expression like this, then he did not give you error. Hit return a function. So this time there is no error. Now let's see the backticks. So suppose in Haskell is a programming language, so where you don't have a loop. Okay, so you can assign a variable like 4 equal to 0. So 4 here is a identifier or symbol. We use this to identify the object 0. Okay, so that's why it is called identifier. Okay, similar, suppose you want to represent the same thing in R. So how we can do it in R? First of 4 is a keyword, so it gives you error because you can't use keyword in variable, right? But if you use the backtick, uh, it loses the ability of keyword. Okay, now 4 become a symbol. Now 4 is a identifier. Suppose if you want to use keyword and operator as a identifier, then you have to use backticks. Otherwise, if you r give the error to you. We have seen what lexer parsing and semantic doing. Now let's see the R evaluator. For R evaluator, everything is a verb function or okay. So more accurate things to say, for a CPU, every if you see the CPU instruction machine code from the language terms, everything is a verb and objects. Okay, and verb is the first things you we have to consider. There is no clauses, there is no helping verb. Okay, only verb and object. If you observe the machine code as a perspective of language world, if you observe the machine code from the mathematics point of view, everything is a functions and variables. Okay, so CPU don't know what is the meaning of because he don't know the symbolic expression. Okay, so this is the duty of evaluation. The symbolic expression is done by the R evaluator before the machine code generation. So plus 1 1, it is a 3 symbol. Okay, um, it is a group of symbols, so you can also say that it is a symbolic expression. Okay, so our evaluator has to know about 3 symbols meaning for the judgment. Evaluation means making a judgment about something. So for now, let's say everything is a symbol except a data structure. Symbol eval what they refer to, and data structure eval themselves. Like suppose any programmer of or you give the data as an input to the R console. Whenever the CPU, not CPU, R evaluator see this data as an input, he think that users want a data. So what he do now, he return the data to the user. Okay, similarly, if he see any symbol, then what he do, he search the meaning of symbol in the environment, and whatever they refers to it, return it. Suppose if I write a symbol sum, then he return a he searched the meaning of symbol and he got the function. So he returned a function to you. Suppose if you type randomly like ABC and you give this input to the R, he R don't know about its meaning. Okay, he's after all after all he see this symbol ABC for the first time. That's why it return error. If you define the meaning of symbol like ABC equal to 1, so this means that ABC has a meaning 1. So now if you give the input ABC, it return a 1 in this case. So this is a function, my fun is a function name, as you can see in the slide. And to call the function, you can also give a direct value. In this case it will give you the result 4. Suppose we give variable or symbol as an input. In this case, what our evaluator do, first he search the meaning of my var symbol in the my function environment. Okay, then he goes to the global environment and he found the my variables symbols meaning. Now he able to calculate the function and return to the user 4. So this is how he got the meaning of any symbol from the computer. Now suppose we give the symbol ABC. Now we give ABC symbol as an input. In this case, what our evaluator do, similar the previous one, first he search the meaning of ABC in the my function environment. Then he goes to the global environment. So in the global environment, as you can see that there is a no the definition of ABC symbols. So now what he do, he goes to the stats environment. So stats environment he also not able to find the meaning of ABC symbol. So similarly, he goes to the graphics environment and empty environment. Now our evaluator stop and he gives error that ABC object not found. So this is things, you can see the all the environment by the search function. If you don't know, I mentioned here few environment here. You can fetch variable from any environment. Okay, so this is a grandfather. It is a function which is represent grandfather. There is a father and son. So in this case, what I am doing, I fetch the value from the grandfather environment. Okay, that's why it return 100, because if I add the 1 plus 99, it will give me 100. So in this scenario, he will fetch the my variables meaning from the grandfather environment. What if I type this? He will give, now he by default it find the meaning of my variables from the global environment. That's why it returns 6 now. So you can decide from where we you want to fetch the variables. Now let's see select function which is available in the tidyverse, and I am defining here data frame which have a identifier name is df, which is present in the global environment, right? But whenever you call the function like select, so first whenever you type this select dfx, our evaluator first create a select function environment. Now he has to eval what is the meaning of df here. Okay, so what he do, he finally found the meaning of df symbol in global environment. Okay, now it's turn to eval the x symbol. What is the meaning of x symbol? So so we know that what is the default behavior of our evaluator. He goes for, if he didn't find the meaning of value in the current environment, like if, like here in the select environment, then what he do, he goes to the global environment, then stats environment, then graphics environment, then goes until the empty environment. That is the default behavior of our evaluator. But this time, as our evaluator goes to the select, uh, goes to the searching for the meaning of x symbol, hardly become stop the R evaluator from the evaluation, and he says that R don't eval now. I will I will manually eval this expression later. So this is called tidy evaluation in the tidyverse world. Why he did that, I will explain in the next video. But all the tidyverse function, specifically deployer, all the deployer function available like mutate, select, filter, all the function use a tidy eval principles. Okay, so I will explain you in the next video, but here let's see. So stopping the R evaluator means quote. Okay, here hardly become stop the R evaluator from the from the evaluation. Okay, that is called quoting. Okay, if you want to unquote this, we have to use here bang bang operator. And bang bang operator I will explain you in the next video. Thank you.